Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video, we're going to make a lock for a thick wooden door. The overview of what's happening is they've got an unusually thick door. I think it's 4-inch. So the question becomes is, how do you lock that door? So at the end of the day, there are not a lot of inexpensive options. There are expensive options. And the easiest and most robust is most certainly going to be a mortise lock. This job is outside of the envelope of what's commercially available, and that's the whole purpose of this video, what we're doing to make a lock for this door. The logic of optimizing. Onsrud catalogs. Onsrud.com, downloads, catalogs, download, production tools, optimize. Optimizing speeds and feeds. It's on page 122 of the Onsrud production cutting catalog. Start off using the recommended chip load and RPM for the material you are cutting. Meaning, start off with the recommended voltage and wire speed for what you're welding. Increase the feed rate, wire speed, until the part finish starts to decrease. So increase the speed rate, meaning you're optimizing. You want to move as quickly as you can through the work until the quality begins to decrease, or you risk moving the part off the vacuum. That's obviously got nothing to do with welding. Decrease the feed by 10%. You push it to the point where something starts to get worse, not better. Come back 10%. Next, decrease your RPM by a set increment until your surface finish deteriorates again. So I would say your voltage. Dial in the voltage until you can tell the weld's just not penetrating, or the weld's just not as controllable or desirable or looks as nice when you're done. Once this happens, increase your RPM until the finish is acceptable. You have now optimized your speed and feed by taking the largest chip possible. Chips is the sawdust, except if you looked at it under a really big set of cheaters, these are aluminum chips in here, and you can see those little curly cues. Those are the chips. There's a really big chip here on whatever I was cutting, but all these little chips are the curly cues. That is the load. That's the chip. That's the load, meaning the stuff that weighs something that's carrying the heat away. Doesn't have anything to do with welding, but that's what chip refers to. It's the piece that is being expelled from the work as a result of the operation that's taking the heat with it. And that's what that all means. So, okay, we talked about jog mode, weld parameter chart, weld parameters, troubleshooting guide. I don't think we have a need to go into it because our wiring diagram, I will likely never refer to this. I suppose I could. Yeah, okay. So, assuming this isn't your first time welding, you may not need to get into this. But if it is your first time, MIG welding guidelines. Okay, so here's what it looks like when you've got a tank. Yeah. I suppose if I did enough. The issue is you got to buy wire, then you got to make sure your tank is filled, blah, blah, blah. Nothing we weld is that critical. So we're not doing the shielded wire process. Welding wire is energized when gun trigger is pressed. Before lowering helmet and pressing trigger, be sure wire is no more than 1/2 of an inch past the end of the nozzle. 1/2 of an inch. So right now I'm a little far out. The bottom line is, if it's too far out, then you're really just spitting. You're spitting metal everywhere. You're spitting metal like I did here because I had so much wire. You can do that and burn the wire down. You can do that and burn the wire down. The problem is you're going to foul up your tip prematurely. So you really want to make sure you've only got you've got the prescribed amount of wire hanging out. Yeah, I'll nip that before I actually start to weld. So 1/2 inch past the end of the nozzle, and tip of wire is positioned correctly on seam. So in this example, they're showing you that you're going to weld 2 pieces of steel together. So right here. This is what it looks like if you're looking at the end of the piece. So end of the piece is this, if this is my piece. But what your gun's going to look like is on this angle here. From this perspective, it looks straight on. But from this perspective, you're angled. And yeah, you're going to be angling it, angling it, angling it, angling it. 0 to 15 degree, depending on what you're doing. You know, the angle is going to be dictated by what you're welding. Conditions that affect bead shape. Very good. You're pushing it versus dragging it. Gun angles and weld bead profiles. Short, normal, long. Short, normal, long. Yeah. What you're seeing here in the push method, when you're welding from right to left, let's say, weld, 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 you're going to look a little bit flatter like this. When you're dragging it, apparently your bead's going to be a little bit higher and perpendicular. If I'm moving in this direction, I'm pushing. If I'm moving in this direction, I'm pulling. If I'm doing this, I'm perpendicular. You're just going to experiment. The way to get good at this is to weld. Right. Gun movement during welding. Normally, a single stringer bead is satisfactory for most narrow groove weld joints. However, for wide groove weld joints or bridging across gaps, a weave bead or multiple stringer beads works better. So what that means is rarely ever have I just welded like this, but sometimes. More often, it's this. I was also taught this. Okay, that's what I was also taught. This, never. This, sure. This, absolutely. Welding is how you're going to get good at that. We use weave patterns to cover a wide area in one pass of the electrode. Poor weld bead characteristics, yeah, all that splatter, splatter. Rough, uneven bead, yeah. Practice will get you good at that. Slight crater during welding, yeah, craters during welding is just more work. Bad overlap and poor penetration. Okay. Good weld bead characteristics. Good penetration, really good. Your weld is even on the top. No overlap. That's this or this. Fine splatter. There will be a small amount. Uniform bead. Yeah, take your time. Make it look nice. Moderate crater during welding. There won't be much. You're going to heat that up and liquefy that as you're bringing in the wire, but nonetheless. Excessive splatter. This is troubleshooting. I'm not worried about that yet. Porosity is a bad thing. That is going to, it says here, gas pockets. It's just optimizing. If you're getting porosity pockets, you're going to have to tweak it according to this stuff. Excessive penetration, probably too much heat, too much voltage. Move faster. If you're really burning through it, you're going too slow, or you got too much voltage hitting it. Lack of penetration, you're moving too quickly. You don't have enough voltage, most definitely. Yeah, you know, incomplete fusion, you need to be able to get in there and liquefy these areas here to get that metal, all three pieces, 1, 2, and your wire to fuse. Burning through, way too much heat, way too slow. Keep moving, keep moving. Waviness of bead, that's all in the hand. You'll learn that as time goes on. And distortion, heat. Heat. You're warping the metal. Excessive heat input. Awesome. Okay, so we're going to put and there's more. Okay, we're going to put this away, or at least in my box. The next thing is we're going to get the workpiece, and we are going to get it clamped down, and we're going to see about getting something welded. So let's move on.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, we have the welder set up. We know it works. Great. Now, what are we welding? Well, here's what we're welding. This is the Yale lock, a 197. This is a rim lock we've talked about. Here it is. Boom. Locked, unlocked. Okay. This little tang here is called a shutter guard. That means if you were to remove the cylinder from the outside without the shutter guard, you would be able to stick a tool in there and manipulate the lock to get in. And you only need to get that open once. I'll show you what I'm doing in a moment. So that shutter lock is there because this little piece of metal is sticking up to prevent it from moving. But when I get my fingernail in there and get it pushed down adequately, which is no easy task, there it is. All I need to do is push that curved piece of metal down. Now I've got my finger over that. Into the shutter here is where you'll stick the tailpiece. And that's what we're welding. It's because the client has such a long, such a thick door. I'm going to put that piece of cardboard back in there to prevent it from locking itself again. The 197 comes with an angle strike. This is meant to be mortised into the rabbet of the frame and into the face of the frame. So you'll create a notched sort of cutout. I could make a visualization in the workpiece if we wanted to do that. I could do it. It wouldn't be the right way. I've never created tooling on two different faces of the tool path. I could create one tool path where I came down the thickness of this with a really long, thin bit and then mortised for this. I could create that. It would not be the right way to do it. A bag of screws, obviously. Okay. Then it comes with its own rim cylinder because it's a 197. It's a single cylinder. It includes a rim cylinder on the outside. I'm not going to use this rim cylinder. I'm going to send it to the client, but I'm going to use a different rim cylinder. And the reason I'm using a different rim cylinder is because the tail pieces that I stock are Kaba Ilka. I don't know that the tailpiece or connecting bar for this Yale cylinder is going to be the best choice for using a Kaba Ilko cylinder. So I have a typical rim cylinder. It's higher quality because it's solid brass. But I'm going to take this long tailpiece and I'm going to weld it here. That's the concept. And then when we're done, we're going to have a really long tailpiece for the client that will go through his door. The idea now, of course, is to make sure that that weld is really good. So that's what we're doing. This is a 7015, which is a discontinued part number nowadays. With a WA8, that might be a Wiser keyway. A WA is probably Wiser. The bow of that key tells me it's Wiser as well, I believe. And what we need to do at this point is remove this tailpiece and get these two pieces so that I can get them clamped down and then weld it. But before we do that, I'm going to make a modification. I don't have my proper locksmithing tool here. Stock tailpiece. This, I think, is an 862 is the part number. It is. It says 862 on it. This is an 862A. That means it's the long version of the tailpiece. Two of the 862s would likely work, but I'm going to take these and weld them together. First thing I'm going to do is I'm going to grind off the end of this, and then I'm probably not going to do anything else to it. I'm not going to cut it to length for the client. He'll have to do that. This is going to be plenty long enough when I've got the body of the cylinder all the way to the back of that tailpiece. That's pushing 5.5 inch. This door is only 4.25 or whatever the client said that it is. So the next thing that we're going to do is we're going to set up that bench grinder that I bought. I'm going to clean off this end. It'd be easier just to cut it with a hacksaw. If I have a hacksaw here, I'll do that. One way or another. I don't want to grind it off, but if I have to, I will. And I'm going to grind the tips of this material so that I can expose the raw steel. And I'm also going to grind very lightly the zinc dichromate off because that plating that's on there, technically it's going to interfere with my circuit as we've gone over. I want clean metal to weld to. No impurities blocking the way. Okay, so that's what we're going to do. Let's move to it now. This is exciting.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, so you can kind of see what I'm going after here. I'm going to put my tail pieces here, ultimately, and I'm going to clamp them down. I'm going to weld them together. First thing we're going to do is set up that small bench grinder that I bought. I'm not going to make a video on setting this up. It's a bench grinder. There should be really very little to do. Get that rolling. Now I'm going to stack them together and grind them kind of together. Yeah, I like that. Nice and straight. Show you what we plan on doing in terms of welding this all together. I'm going to want to put this all in there as straight as possible. We're going to clamp these down. The reason I lifted it off is because I wanted to get my three-way clamps over the edge of it. So, looks fairly straight. Yeah. One way it's straight because of how I stack them together. They should be flipped like this, which is the case. Okay. Whatever. Will this work? It should. It's not awful. Yeah, the clamp's fairly tight. And that's why I lifted it off, so that I can get my three-way clamp in there. Let's bring in the other three-way clamp. Yeah. Okay, is that in the right spot? I think it'll be kind of okay. Well, you can see what we're going for. I'm going to clamp my first tail piece just simply down, not overly tight. It doesn't need to be, because plus it'll pull the clamp off my fixture. It doesn't need to be tight, just needs to hold it in place. Now, bring that up there. Let's get that down. I'll be able to get my nozzle in here. The issue is going to be, are these straight? So, taking a piece of aluminum that I believe to be relatively straight, putting it in there and holding it as a straight edge to make sure that the two pieces are actually flat against each other, and it looks like it is. They're flush. Little tweak, little tweak, tweak, tweak. Don't get greedy. Yeah, if I was going to make a lot of these, I would most certainly think about how I might fixture all that up. All right, now at this point, all that really matters is it's time to weld. What I need to do at this point is to get my welding mask out and install my diopter, as I had mentioned. This is a Lincoln Electric helmet, and it will auto darken on me. Shade, sensitivity, delay time. I'm just going to leave them right in the middle. So that's what that welding mask looks like. You get it dialed in on the sides, and you just do that, and you're ready to roll.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.